Thank you, Chloe. Yeah, we had some of the other classes, not algebra, but some of the other classes had trouble seeing yesterday, so I don't know, something funky was going on. All right, so this is just a continuation of what we started yesterday. Quadratic functions in standard form. And what we're looking for here is the standard form is basically you have some number. Get this thing to right, that would be good. So you have some number in front of the x squared, they call that a. Then you have some number in front of the x term, we call that b. And then finally there's just a constant number, we call that c. Okay, so that's just a regular number. So what we found in this thing so far is that if you take the c value, that is your y-intercept. No matter what, that's your y-intercept. If they don't have a c value listed, that means your y-intercept is 0. So the other thing they were interested in was called the Axis of Symmetry. I guess we'll abbreviate since I ran out of space. Okay. And again, that's the idea that if you have a quadratic graph, which is U-shaped, right, then you have a line that goes up through the middle that basically divides the parabola into two mirror images. Okay, so the way we find the axis of symmetry is a little formula, but kind of an important formula, so this is a good one to know. So the way we figure out what the axis of symmetry is, it's x equals some number. So it's going to be x equals minus b over 2a. So this one's kind of a big deal. Okay? So basically what you do is whatever the number is in front of b, you switch the sign, and then divide it by whatever a is and double it on the bottom. Okay? So what that gives you, that x value gives you the axis of symmetry. So that'd be this guy here, x equals some number. Then it also gives you half of the vertex. We haven't talked about the vertex yet. So the vertex is this point down here. In this case, it's a minimum. If the graph is flipped around, it's a maximum. So this is our vertex. Okay. And that gives us our first point of the vertex, is that x value. So then we need to figure out the y value. So what we do is once we get a value for x out of this guy, right, we come back up and we plug it in wherever we see x in this guy, and that will give you your y value, because remember, all this stuff equals y. Or sometimes I use f of x. Okay, but as we've always said, f of x is just a fancy version of y. It's like y is the coffee from the gas station, and f of x is the Starbucks. They're both coffee, but one's a little fancier than the other, right? And more expensive. Okay, so that's the basics of what we covered last time. So let's go ahead and work through a couple more problems. These are going to be very similar to the ones we ended up with yesterday. So let's go ahead and do that. All right, so again, we're looking for the y-intercept, the axis of symmetry, and the vertex of each function. All right, so y-intercept, that's easy. That's just our c value here, which is 12. Yeah, good, Chloe. So y-intercept equals 12. Good. And then the axis of symmetry. So that's going to be the x equals minus b over 2a. All right, so y-intercept check. Axis of symmetry. So we switch the sign on this guy, minus 5, right? Take this guy and double it. So 2 times 5. So it's going to be negative 5 over 10, which is negative 1/2. So your axis of symmetry, look at this guy, axis of symmetry is x equals minus 1/2. All right, axis of symmetry, check. Okay, so the vertex, and this one's going to stink a little bit. The vertex is plugging in, unfortunately, this 1/2 in wherever we see x. So we have to put, actually it's a negative 1/2, so we put a negative 1/2 in here, and another negative 1/2 in here. And that'll give us y. All right, so enough blue already. Let's change colors here. All right, so this is going to be y equals 5 times negative 1/2 squared, and plus 5 times negative 1/2 plus 12. All right, so negative 1/2 times negative 1/2 is actually positive 1/4. So 1/4 times 5, so this is going to be the ugly fraction of 5/4. Okay, then we go plus, so we have 5 times negative 1/2, so this will actually be negative 5 over 2. And then this guy will be plus 12. Okay, so if we don't want to deal with the ugly fractions, here's what we can do. We can turn these guys into decimals, and I'm perfectly fine with that. Because most of the world works in decimals, they don't work in fractions for the simple fact that they don't like fractions, right? So the first guy, that's going to be 5/4. If you're not sure what that is as a decimal, go to your calculator. Because 5/4, remember that fractions are just fancy versions of division problems. So break up your calculator. It's a little fun we were having in Algebra 2 yesterday. And you go 5 divided by 4. So that's 1.25. Okay. I'm going to put that probably across the top here because we need some space. So, a second. All right, so let's finish this guy upstairs here. All right, so we're going to have y equals 1.25 minus, now we do 5 divided by 2. We'll break out our calculator again. We say 5 divided by 2. That's going to be a negative 2.5. So minus 2.5. I don't know why this thing doesn't like to work at the top of the screen, but it really doesn't. Okay, and then the plus 12. Okay, so we just add those guys together. So we say, clear it out, we go 1.25. Oh, that's 1,025. No, not today. 1.25 minus 2.5, and then plus 12. So 10.75. I am perfectly fine with that answer. Okay, so that's going to be your y value for your vertex. So your vertex is going to be minus 1/2 or minus 0.5. You can write it as minus 0.5 if you like, and then 10.75. Okay. So that one was a little bit of a pain just because we had to deal with fractions. Okay. So this is pretty much the same stuff we were doing yesterday, except I don't think we had to deal with any fractions yesterday. All right. So let's try another one here. So we'll start off with y-intercept. That's easy, right? Change colors here. So our y-intercept on this guy, again, is just the regular number. regular number here is just 5, right? Okay, good. So next up, we need to figure out the axis of symmetry. So we use our x equals minus b over 2a. So again, with this guy, switch the sign on the number in front of x. So he becomes negative 12. And then take this guy and double him. So 2 times 4. Okay. So then that's going to be minus 12 over 8, which is minus 3/2, or minus 1.5. We might use that when we get to the vertex. Okay, so axis of symmetry, so we got our y-intercept, right? Axis of symmetry, we just figured out as x equals negative 3/2, or 1.5 negative. Okay, all good there. All right, so then to figure out the vertex, we already know the first guy is minus 1.5, so we just have to figure out the second guy, right? And this is where we have to deal with, well, we won't deal with fractions this time. We'll work with the decimals, okay? So y is going to be 4 times negative 1.5 squared plus 12 times negative 1.5 and then plus 5. Okay. Calculator City. Let's go over here. So if you remember that when you square a number, you're going to get a positive anyway. You don't really have to fiddle with the negative sign here. So we can just clear this out. We'll say, okay, that's 1.5 squared. So this guy here becomes 2.25. And the next guy's going to be minus because we've got a plus and a minus. So then he's going to be 12 times 1.5. So it's going to be minus 18. And then plus 5. So we add everybody together here. So we've got 2.25 and minus 18 and then plus 5. That's negative 10.75. That's interesting. We've got the same number except the negative version, right? So minus 10.75. So that goes here. Minus 10.75. That's your vertex. Capiche? I'm pondering them. Grab some water here. All right. So let's look at a couple more. Pretty much second verse, same as the first. I'll do this so I can try to keep things where they should be. All right, so same stuff. All right, so the first guy's always easy, right? Let's get some different colors going. How about some blue? I haven't had any blue in a while. So y-intercept is 12. And sometimes they may want it written as a point. Remember, the y-intercept is when x equals 0. So another way you could say this is you could say that it's 0, 12. Okay. For right now, I'm cool with the y-intercept equals 12, but like I say, sometimes on maybe a standardized test or something like that, they may write it as 0, 12. So just know that the y-intercept is when x equals 0. So for the y-intercept, the first number is always 0. Just another way to think about it. Okay. So axis of symmetry. So we're going to go with x equals, so we take this guy, and we switch him, right? So he's going to be a positive 6. And then the bottom is going to be 2 times this number. There is no number, so we know that that guy's 1. Right? So it's just 6 divided by 2. So in this case, x equals 3. So that is your axis of symmetry. So y-intercept check, axis of symmetry check. Whoops, going to the wrong problem, not check. So there we go. So those two guys are taken care of. All right. So then this one's nice because it's not a fraction. So we go ahead and just pop 3 in wherever we see x up here. So we're going to pop a 3 in here and a 3 in here. Okay, so that's going to give us y. So let's get our vertex started here, right? So vertex, first number is going to be 3. Second number we're about to figure out, right? So second number we got y equals, so we've got 3 squared minus 6 times 3 plus 12. Cool. All right, so 3 squared, that's going to be 9. Minus 6 times 3 is minus 18. And then we've got 12. Okay, so 9 and 12 is 21. Minus 18 is 3. So this guy happens to also be 3. And that's your vertex. This is everything we need right here. Okay? Questions? I think we're starting to get the hang of this, right? Cool. All right, so next one, same deal. So this one, y-intercept. Yeah, let's change colors for this side. So the y-intercept here is going to equal 40, right? And then next we figure out the axis of symmetry, which is that whole minus b over 2a thing, right? Which means we switch the sign on this guy, so we make him negative 16. And then we take the second guy, the minus 2, and we double him, right? So then that's going to give us negative 16 over negative 4, right? 2 negatives gives you a positive. Let's just destroy that 4, shall we? Some days this thing acts weird, what can I tell you? All right. Minus 4, that's a little better. So that's just going to be positive 4, right? So axis of symmetry is x equals 4. So we've got that guy, we've got our y-intercept. Cool. Now we've got to have our vertex already. That's a good thing. So vertex is going to be, first guy's 4. Now to figure out the second guy, we got to plug some numbers in, right? So we're going to do y equals minus 2, and then 4 squared plus 16 times 4, and then plus 40. So just to be on the safe side, we'll use our calculator on this guy once we get there. All right, so we've got 4 times 4, that's 16. Then minus 2, so 16 and negative 2, that's going to be minus 32. The next one is 16 times 4. Yeah, we better do this, right? So 16 times 4, so that's 64. So we have plus 64 and plus 40. All right, so where are we going with that? So we'll go ahead and do the calculator again. All right, we already got the 64 in place, so we're going to add 40 to him. And then we're going to subtract 32. So this guy is 72. All right. So that vertex is pretty high up. That's like 72 above the x-axis. Reason for that, again, is this guy's negative, right? which means you're going to have a vertex that looks like this up here at the top. And again, this number here is going to be 4 for x and 72 for y. And it's going to go down from there. And we know it's going to go down from there because our intercept is at 40, right? So if this is 4, you come over here to 0, and you'd be hitting at 40. So it'd be something like this. So like over here, this would be 0 and 40. Okay. So we know this guy's upside down. It tops off at 4, 72, and it goes across the y-axis, the y-intercept, at 0, 40. Beautiful. Okay, so we got our procedures down. Let's see what other kind of curveballs they can throw for us here. It says compare each function to f. I guess this is f right here. Says which function has the lesser minimum value. So minimum value again is when we have a parabola that's going up, right? And we want to know where this thing bottoms out at. Oh. Okay, so what's the lowest point we see on this guy? What's the lowest value for x? Remember, f of x is just a fancy version of y. What's the lowest y value on this particular chart? Where are we at?
Oh, so it's just less detail. Yeah, yours would be different. Oh,
what's the smallest value we see for the f of x? So it's definitely symmetrical, right?
Okay,
so here we got a 0, here we got a 0, here we got a -3, here we got a -3. Looks like we're bottoming out here, right?
Oh,
okay. Okay, good. So that's this point right here. So the lowest value for this guy is going to be -4. Okay, so then it says for us here, let's compare this guy and see where he bottoms out at. Okay. So here we would say we're going to do our minus b over 2a thing, right? So I've got -8 over, then I've got 2, so I double up 2 times 2, right? So in this one, we're going to have -8 over 4. So our x value for this guy, that's going to be the bottom of the thing, is going to be at -2. Okay? So now what we're going to do is we're going to throw -2 in every place we see x. So we'll put a -2 right there and a -2 right there. That's a nice looking arrow. I like that one. All right, so then we're going to have 2 times -2 squared. And then we're going to have plus 8 times -2, so that's going to be -16, right? So it'll be -16 and then plus 3. All right, so -2 times -2 is going to be +4, right? +4 times 2 is 8, so we've got 8 minus 16 plus 3. So we do 8 and 3, that's 11, so now 11 minus 16 is -5. So the vertex on this guy is going to be -2 minus 5. So -2 minus 5. Now the question was, which one has the lesser minimum value? I've got my negative sign here, that would help. So this guy bottoms out at -4, but this guy bottoms out at -5. So in this particular case, the one that has the smaller value would be this guy, because his vertex is lower, right? So that's our boy. All right, so the next one, we're going to compare him to the same graph. So we're still looking to see, is this one going to go lower than -4? Okay. All right, then, so same deal. We're going to go figure out our vertex here. All right. So this guy, I'm thinking probably is going to be lower. And here's why. Because, check it out. The y-intercept of this guy is -3.5. That's almost -4 right there. So he might be smaller pretty quickly, but we'll see. All right, so again, same deal. We're going to do our x value of our vertex. So that's going to be minus b. So again, we don't have a number here, so he's -1. And then over 2 times the number in front of x, which is also 1. Right? So unfortunately, that gives us a -1/2. So now we're going to plug that in, which as we know is no fun. All right, so to figure out y, we're going to say, so we know that our x value is -1/2. We don't care about the x value because we're interested in the y value. That tells you the minimum of the parabola. So we'll go ahead and plug this guy in. So we're going to have -1/2 squared. And then we're going to have -1/2 and -3.5. So I can tell you right now that this guy, it's going to be close, all right? But I think it might actually be a little higher. So I think the low point might be the other guy. But let's check it out. So again, let's do decimals this time. So we know that 1/2 is 0.5. So I'm going to take 0.5. And we know it's negative, but when we square it, we know it's going to be positive. So we just square it. So you get 0.25. And then minus 0.5 and minus 3.5. All right, going to be close. So we've got 0.25, and we say minus 0.5, and then minus 3.5. So that's 3.75. So our second point is minus 3.75. It's close, but it's still not -4, right? So in this case, this guy up here is going to be the one that has a lower value, because this guy bottoms out at -3.75. He bottoms out at -4. And this guy down here, we said bottomed out at what? -5. This guy over here. Okay, see what they're looking for? That obnoxious noise you hear is me cracking my knuckles, by the way. It's a bad habit of mine. People say you're not supposed to do it, but I do it anyway. Sorry. What don't you understand, Chloe? Oh, the box one? Okay. Well, let me show you what that one is. Maybe we'll do some Desmos here. So the box one is just like plotting points instead of having an actual function. So let me break out the des, and I'll put some points on here for you. So let's see. Remember how to do this actually. Doing this off camera, by the way. I just want to make sure I had it right. 2. So let me bring it into focus here. Let me write down these other points because I won't be able to see them here in a second. 1 moment, please. Okay. So here's what we got. Incoming. All right, so I've already plotted 2 of the points. So I've got 1, 0 right there. Then I've got 2 minus 3 right there. Okay. So then the next guy was minus 3, 4. So we go. It was minus 3 minus 4, right? No, it's 3 minus 4. That's right. That guy. 2 more points. So then we had 4 minus 3. There's that point. And then finally we've got 5 and 0. So if you look at our points, if you would connect the dots on these guys, we'd get a parabola, wouldn't we? So what they're asking us is they're saying, well, what's the lowest point on this thing? So this one, the lowest point is at minus 4. Okay. Now let's go ahead and put the other 2 on here. I gotta pop Desmos down for a second because I didn't see what we had here as far as the other functions. I didn't write them down. Give me just a second here. All right, so let me write these other 2 guys down real quick. So we've got 2x squared plus 8x plus 3, and then we've got x squared plus x minus 3.5. Okay, got it. All right, so let's bring Des back into the picture. All right, so this guy, we're just going to put in the function. So we've got 2x squared. That's x squared. And then we've got plus 8x. And then plus 3. Right here. All right, so see this guy, as predicted, his vertex was at minus 2, minus 5, which is lower than this guy. So just picture this guy. I'm not sure how to connect dots on this thing. You probably can, but I don't know how to do it. So that's the point, is that they're showing here that this guy actually comes down lower than this guy. And then our last guy here, we had x squared. And then we had, let's get him out of here. And we had plus x minus 3.5. So again, we see this guy's pretty close too. See, he's at minus 1/2, like we predicted, and minus 3.75, but he is still higher up than this guy. That's what they're going for, so maybe the visual helps out here. But the box thing is just saying, well, instead of giving you a function, we just gave you some points. If you plot those points, that's what it's going to look like. So that's why I said we were looking for the smallest y value, or f of x value, which is this minus 4 right here. Okay? I guess I could have labeled these guys. Yeah, there we go. That's nicer. Okay, does that make more sense now? So this guy bottomed out at 4, this guy bottomed out at 3.75, and this guy here bottomed out at minus 5. Yeah, sometimes getting to see it helps a lot. So that's a great question, Chloe. Thanks for bringing that up. Okay. All right. I don't know if let's check out the next one. I don't know if we have time for one more or not, but we'll take a look here real quick. So let's thank the Des for stopping by, and we'll drop him out of the picture for a bit. Get my cursor there. There we go. All right, so we've got time to finish this one. Okay, so this is the same kind of problem. So we'll probably save that for next time. Let's see if there's any other ones we can do real quick. Write each in standard form. Yeah, it's going to take a minute. That's going to take a minute. Yeah, it's going to take a minute. Yeah, I'd say let's call it there. Yeah, we don't really have enough time to get another one in today. So we'll wrap this stuff up next time. Okay. All right, I've already got attendance, so we're good to go there. We'll shut down the recording, and hopefully we'll see you all tomorrow.